Hi, it's Miss Patterson. Today we're going to go over just a real simple summary of acid bases and buffers. So when we study pH, what we're really studying is the chemistry of water. Water is a good solvent and can dissolve many different substances, and its ability to regulate ions allows for a wide range of chemical reactions to take place. There's a reason why your body is around 60% water. It's really good at what it does. So when we talk about pH, we need to discuss water. Water, of course, is H2O. We know that it is going to be a polar molecule. We know oxygen is very electronegative, and this is kind of one of the reasons why water is able to do what it does. Water can disassociate, and when it disassociates, it can go into what's called a hydrogen ion, which is an H+. It can also be a hydroxide ion, which is an OH negative. This oxygen, really super electronegative. Remember, previous video, very greedy for electrons. It wants all these electrons, and when it can't get any more, it's going to start to attract hydrogens to it. This hydrogen no longer has an electron because it's positive, so it's just a proton, and this will get attracted back to this oxygen and turn it back into water. So when you have a neutral pH, you have similar number of hydrogen ions, similar number of hydroxides that come together, and they're going to form the water molecule. pH stands for per hydrogen, and so it's a measurement system to indicate your hydrogen ions, that H+ in a solution. Your scale goes from 0 to 14. The closer I get to 0, the more acidic I am. The stronger my acid is, the closer I get to 0. The closer I get to 14, the more basic my solution is. Sometimes they'll say more alkaline. It's a more alkaline solution. So each step of the pH is a 10-fold scale. There's a difference in hydrogen ion concentrations. So when I look at the 7 pH on my scale, it's neutral. I have almost the same amount of hydrogen ions as I do hydroxide ions, and that's going to give me water molecules. So a pH of 4 is 10 times more acidic than 5. The same holds for pH values above 7. So sometimes people get confused. They think if I'm getting bigger, I'm getting more acidic, where you're actually getting more basic. The smaller my number, the more acidic I'm getting. So if I have 4, it's going to be more acidic than a 5. So if I go above a 7, I'm becoming more basic. So each is 10 times more basic than the lower value. So if I have a 13, which is a very strong base, it's going to be 10 times more basic or stronger than a 12. You can have what are called litmus papers. They're small little pieces of paper, and you can put them in a solution, and it can read the number of hydrogen ions that are on there, hydroxides, and it can change the color. If I'm more red, most of the time, it's going to show some type of acid. If it's a blue, purple, it's going to be some type of base. Acids are going to be any compound that forms hydrogen ions. That means hydrogen ions disassociate from the molecule that's there and will add to the solution. I can have something like coffee is acidic, tomatoes are acidic, and I can get stronger as I go up. Your stomach acid is really acidic. It's also why when you throw up, it burns the back of your throat. If you ever have acid indigestion or heartburn, it's acid coming up into your esophagus causing it to burn. So you'll take a base, some type of stomach tablet, and what you're doing is you're adding these hydroxide ions into your stomach to help neutralize your stomach acid, and you're turning it into water. And that kind of helps to lower the acidic level. It releases that burn that's in there because you're combining those two ions to produce a water molecule. There's a reason why we do need some of these hydrogen ions to be in our system. We use them for some types of pumps. We use them for when we do cellular respiration, we'll talk about that we have to have a concentration gradient that allows this oxidative phosphorylation to happen when we make ATP. Again, we'll go more into that, but we have to have this type of concentration gradient for certain things to work. Bases are going to be compounds that are going to release those hydroxide ions into a solution. You will see at times they'll be called alkaline, or the alkaline level will rise, or the basic level will rise, means the pH value is rising. That can be baking soda, soap, bleach. A lot of cleaners are bases, and they have a real slippy, slimy texture to it. So if you've ever cleaned a tub like with Comet or some type of cleaner, and then you go to wash your hands and it feels real slicky, it's that base in there. It's also why when you don't wash soap off very well, it kind of burns. And that's another misconception. People believe that only acids burns. Bases can burn just as bad as an acid, but they're really good cleaners. So buffers are weak acids or bases that can react with a strong acid or a base to help to prevent a sudden increase or a sharp change in pH. So the human body generally stays between 6.5, 7.5, and when it gets out of that range, it doesn't do well. Now, an exception is your stomach acid is a 1, but for the most part, most everything stays between 6.5, 7.5. So let's say we have some blood, and human blood stays around 7.4, and something in your body has caused the pH to rise. And so now it's become more basic and it's come up to an 8. So your body has to make a product that is going to be able to help bring down that level. It's creating a homeostasis or a balance between the two. So carbonic acid can go in and it's going to start producing these hydrogen ions. These hydrogen ions are going to be bonding with the hydroxides that are forming on the pH of the 8. So this has a bunch of hydroxides. This hydrogen ions are going to attach and it's going to help neutralize it. It can make water. It's going to help lower that pH. So the pH will lower back down to 7.4. Then if it happens to drop even more and it goes down to, let's say, 6.7, the body can make a bicarbonate, and that bicarbonate is going to make hydroxides. The hydroxides are going to come in and they're going to bond with all of these hydrogen ions that are forming in the blood. And this is going to help neutralize it to help bring the pH back up to 7.4. So these work in tandem to make sure that we're bonding, pulling apart to keep our pH at certain levels. And these are your buffers. They're going to help prevent these sharp spikes. There are some experiments. We're going to do one in our class where we're going to be taking acids and bases and putting them into solutions. And if I take an acid and I just put it in plain water, the pH is going to rise. There's no buffers in it. All it is just water molecules, but the water molecules become oversaturated with these hydrogen ions that the pH is going to lower to a 4. Whereas if I have another beaker, and let's say that beaker has some type of potato, I've blended up a potato because it's made of cells. If I do something like a chicken liver, I blend that up. Livers are made of cells. Anything that's a cell is going to have a buffer in it that's going to try to prevent that spike in some type of increase or decrease in pH. So let's pretend that this beaker, its pH is 7.4. I start adding an acid to it, all of a sudden you're going to expect, and hey, that's going to start dropping and dropping fast. But what happens is the cell is going to release those buffers and it's just going to drop a little bit. It's going to try to keep it at that level. Of course, there's going to be a point where it is going to fall over if you add too much into it. But your body is going to try to regulate that out as quickly as possible so you don't have a big change in pH flux. So these hydrogen ions are going to be produced by the buffer. That's going to help counteract the hydrogen ions being added by the acid. And then you're going to produce a neutral effect, which is going to help out with the cells. All right, that was just a very simple, very quick overview. Acids and bases are a lot more complex. There's a lot of math that goes behind it. But for what we need, this is a very simple overview for what you need. All right, we'll talk to you guys later. Have a good day.